measures of central tendency. Sounds really complicated, but you've already done most of this stuff before in other classes. So it shouldn't be too bad. The mean. You can tell me what the mean is. A lot of times we call it the average. We have to be careful because sometimes the mean actually stands for something else. But in math class, yeah, the mean is simply the sum of the data. It's kind of the average, or the sum of the data entries divided by the number of entries. Or if you want to write the average, if that makes sense to you, you know how to do that, then that's fine. This is more of an official definition. The population mean. So in other words, this is if the mean we're dealing with is a parameter, correct? It's of the population. We have one little notation for that, and then we have another notation over there. You see sample mean. That means if it's a statistic in that case. We have two separate notations for it so that we can be very clear in our work. And really it's just so that as mathematicians we can be lazy and we don't have to write stuff up, right? So for population mean, I can make it bigger if you need to, or I guess I can't. That is a kind of a U. It's actually mu is what it is, okay? But it is kind of a U with a tail on both ends. Actually, if you think about it, it does kind of look like an M, right? Mu, right? It's a Greek letter, which will always stand for the population mean. So whenever you see mu, you should know that that's what it's standing for. And then there's that sigma again, which means add up all x. Well, what's x? Well, those are your data entries. So sum all your x values and divide by a big old capital N. The big old capital N is telling us that that is the population. If you see the capital N, that means it's the number of people in that population. Sample mean. So this is if it's a statistic. It's x bar is what we call that. It's really just x with a bar over it. Okay. It's still the sum of the x values, or the sum of the values that we have divided by. Now you notice they use a lowercase n, which would signify that it's not the entire population. Okay. Again, it really boils down to a little bit of laziness and preferred use of symbols than writing things out. Okay. So it says the prices in dollars for a sample of room air conditioners are listed. Determine the mean price of the air conditioner. So will I be finding mu or x bar? Very good, it'll be x bar because it is a sample. So to do so, it says right up here that to get x bar, I have to sum up all the x values and divide by how many there were. Well, I'll tell you how many there are. There's 1, 2, 3, 4, 5. There's 7 of them. You take care of the numerator there of summing the entries. Does anybody have the sum of the entries yet? I'm assuming most of you just have the answer already. 3,590, is that agreed upon? Okay, so that'd be the exact answer, but normally if we're going to be dealing with this, we're going to have some kind of an approximation. So that comes out approximately, I have 512.86 is where I chose to round, seeing the directions didn't really say. And so what was it again, 512.86, do we agree on that? Okay. So again, that's the average. Questions on that? We are going to end up, when we start doing calculations, and I'll explain why we use the mean, but we will be using the mean as we go further along in this year. We will not be using the next vocabulary term, which is the median. Okay? And again, I will explain why that is as we go further this year. Really, it boils down to the mean gives us one for sure answer for what we're looking for, where the median could give us numerous answers. Again, could, doesn't always. This is a fairly lengthy definition, so please paraphrase as necessary. It's really the middle data entry is what it is. Okay. That's if you sort them in ascending or descending order. Or you could say it's the point where half the data would be above that value and half the data would be below that value. It's basically quartile 2 for those of you that remember the box and whiskers with interquartile range and all that good stuff. Quartile 1, 2, and 3. It's basically quartile 2, so that 50% of the data is above, 50% below. Again, if they have an even number, that's where median has a problem. And so then we would just average those two final numbers as we work our way in. So the way that you've been taught to find median is to take those values, and we're going to use the ones from up above and put them in order. First, it says either ascending or descending. It really doesn't matter. So normally we do ascending, I believe. So what would be the lowest value then from up above? Okay, so let's put them in order first. Okay, followed by 440. Now, in this case, if you have multiple entries, like I believe 440 happens twice, do you write it both times? Yep, we take it into consideration both times. For what? 70? 480? 500? 840. Okay, so that's all of them. Let's make sure. 1, 2, 3, 4, 5, 6, 7. All right, yep, it's all 7, right? And so then to find the median, what have you been taught to do? Yeah, just kind of cross off one from one end and then the other, work your way back in. So in this case, apparently 470 is the median. Do you agree that 50% of the data is above that number and 50% of the data is below there? There's 3 on each side, right? That's what the median does for you. Okay? So you could possibly see how that could cause problems when we do greater calculations. Okay? Because what value up here does the median really not give a whole lot of weight? 840 does not get a whole lot of weight as far as median is concerned, does it? How about in the mean? Did the mean give it respect? Yes, because look at the difference between the new numbers. The median was 470, and what do we have for the mean? It was like 512 or something like that, right? So it definitely gives that, it gives all numbers power. Where the median kind of, it's just an arrangement. See how that could cause a possible problem. It's not giving all data entries as much weight. Mode. What's the alliteration that we use there? Mode and most, right? The data entry that occurs with the greatest frequency or happens the most, right? Let's face it, that's what that means. I've unfortunately probably already given away the answer to example 3. Yeah, it's the only one that happens a duplicate time, right? And it happens twice, which happens the most. It is 440. What do you do if none of them repeat? If none of the data entries repeat? No mode. What if all the data entries were the same? No, then you once again say no mode. We're not going to waste our time doing that. Okay. Make sure there is a legit. What if only like 2 of them tie? Do you think it's worth writing down both of them? Probably. Be logical. Once it gets to a certain point, it's really not worth your time writing them all down, right? Okay. Questions on the 3 M's? Mean, median, and mode. All right. So why don't you go ahead? I will pause the recording and go ahead and give this one a try. You may notice that, well, at least on mine, they are already ordered for you, right? So go ahead and give it a try. And those of you listening to the recording, please actually pause it instead of just waiting to see the answer. Well, let's find out how that went. So we are to find the mean, median, and mode. So for the mean, am I determining mu or x bar? Which symbol did you use? You probably just wrote down x bar without even thinking about it, but you have to actually stop and think. Is it x bar or is it mu? X bar, why? It says sample ages. Okay, so be very careful. It is x bar. And you take the sum and you divide by how many there were. And for my x bar, I got 23.75. Okay. How about mode? 20, very good. And median. What'd you get? 21? 21.5? Which one is it? 21.5? Because I believe if we do this 1 from each end, okay, I'm lazy, 2 from each end, No, it's not. It's using my knowledge. So it's between 21 and 22, correct? Would be the middle of there, and so 21 and a half. Because you average those two numbers once you get there. So then the next question is, which measure of central tendency, which is all of these, do you know why it's called central tendency? It tends, this is where the center tends towards, right? Which best describes a typical entry for this example? What do you believe represents a typical entry? Okay, median. Okay. And why do you say median? Okay. Okay. What was said there is that because we have that 65, which is kind of a very differing data entry than the rest of them, a typical entry would tend a little bit more towards the median. That's very possible, right? And some would say mean, and you could convince me that the mean, because you're saying that's the average of all the data sets, or the average of all of them. But you'd have to look, I would say probably in this particular case, median probably is the best because of that bigger entry. Okay? Realize if there isn't a bigger entry, there won't be a whole lot of difference between the median and the mean. Okay, especially if it's a very symmetric data set, and I'll show you what that means in a little bit. So a few more things to talk about here. A weighted mean. And luckily we're in school because that's one of the places that it gets used a lot. A weighted mean or a weighted average. It's basically just saying that each data entry does not carry the same weight. Because in the previous data entry, they all carried the exact same weight. They all were counted the same amount, right? They were all counted once. Here we're saying that some of them are perhaps more important than others. And so they're going to be, you could say counted more often, but they're just going to give more weight. Okay. But I think the last one had, what, 16 entries in it? So each one of them was 1/16 of the total, right? Well, here, that's not necessarily going to be the case. And so you're going to want to get really good at reading these formulas. So X bar, so it's a sample mean, is equal to the sum of, and then in parentheses, X times W. That is a times. Okay. So X is pretty much that entry that you're talking about. W then is probably what? The weight. Okay, how much weight will you put it? And then you divide by the sum of the weights. That's not going to make a whole lot of sense for the one we do because the sum of the weights is going to be 100%. So we're just going to divide by 1. But in some cases, it may be different. Yes? Yes. This one will always be X bar. They'll call it that. Okay. Primarily just due to laziness, because all they would really do is just put mu in place of X bar if it was the population. So, yeah. So they're just going to keep it X bar for this one. Okay, good question. So now, if you were given this formula and you didn't see the example right down below it, what I would do is I would try and figure out X times W for each case so that I could add them up, right? And then I would be able to add up the W's. So I would make some kind of table or some way to organize this data. So here again is probably the primary example of where you would use this. There are others. You have 5 different scores perhaps in this class, and 50% is for your test average. So they just take your test average, that's going to be 50% of your grade. You got a midterm and you got a final. Those are each 15 and 20 respectively. 10 for your work in the computer lab, and then 5 for your homework. Okay. I'm assuming most of you would prefer that this is not the weight that we carry, okay, but in some places it is. Your scores then, this is what you've done. You got an 86 on your test average, so that's pretty good. 96 on the midterm, so you had it figured out. Apparently you forgot some, because on the final you got an 82. 98 in the lab, and 100% on your homework. All right. So the test mean right here, you see I've organized it. Here you go. Here's your X or your score. You got an 86, 96, so there's all your values. So what weight should I give to the test mean then? What weight? Now, 50%, so how am I going to write that though? 0.5 is going to be the weight you're going to give that, because that's going to contribute to half of your grade. It's going to come from that. Okay. So let's just do the X times W for that one, because this number might not really make a whole lot of sense to you. So we're going to take the 86 times 0.5. So in other words, what's half of 86? 43. How does that number make sense, though? I got 43. That's failing, isn't it? Yeah, we have to add them all up. So we're basically saying that this 43 is contributing. We know that the total is going to be 100%, right? So that my particular test mean is contributing 43 to that overall 100 at the end, right? Does that make sense? So now does that look a little bit better? Obviously, if I allowed it to contribute 86 and then kept adding, I'd go over 100, right? If I kept going, that would be a problem. Okay, well, unless you want the A plus, right? So now our weights are probably pretty simple. You just have to pull them from the information above. So 0.15, 0.2, 0.1, and 0.05. Make sure you do that last one right. 0.05, not 0.5. Yeah, I wish it was 0.5, right? That would be good. But it's unfortunately 0.05. Okay, and I think this is calculations we can probably all handle, right? So again, then your midterm kind of contributes about 14.4 to your total. And the final gives you 16.4, and then 9.8. Does it seem weird to you that the final that you got a lower score on contributes more to your total in the end? No, because it's weighted higher, right? Now, had it done considerably worse on the final, they may have contributed the same amount, right? Which you really don't want to have happen if they're weighted higher, okay? So here you notice that, yeah, this is what they've contributed to that overall 100% at the end. And I know it's 100% in the end because if I add those all up, right down here, the total weight just ends up being 1, right, or 100%. That's not always going to happen, so that's why they give you this formula up here so that you would just divide by that in the end. But let's face it, I'm just going to divide by 1 in this problem, so it's pretty much whatever I get in that other column, right? Okay. And so we got a 43 and 14.4, 16.4, 9.8, and a 5. So this person's overall percentage ends up being 88.6. Again, you would actually take that 88.6, which is kind of the numerator up here, and divide by, well, 1, so 88.6. So do you see how it kind of did give more weight to the test mean in the final than it did to everything else? Because you would think if you got 198 and a 96 on the other stuff that it should pull the grade way higher, right? But you notice how it stuck to this kind of 86 area because that carried so much more power. Okay. Any questions on that one? No? Okay. This will possibly prove to be a very important one for you, but this is unfortunately approximate. Now, it has to be an approximate because when you are given the frequency distribution, are you actually, if that's the first thing I give you, am I actually giving you every single data entry? No, I'm giving you a nice little table that has organized it for you. Okay. And so what this will do is instead of you trying to figure out what all the data values were, we can approximate the mean from here. Okay. And this will be very helpful. And what it says to do, again, you're going to have to get used to reading this, is it says to sum x times f. Well, x is just your entry again, and f is the frequency. How frequent does it happen? Now, this x, though, does have to be the midpoint. That's probably pretty important. See, x has to be the midpoint, and f is the frequencies. And n, you notice, would just be the total number. Okay? This one's going to be big. Okay? So again, this first midpoint is 12.5 down here in this example, and then the frequency is 6. So is it possible some of the data entries were like 10 and 11 and 12? Is that possible, right? Do I know that, though? Do I know what they were? I do not know what they were. Okay, so can I get a true average or a true mean? No. So that's why this is an approximate. And I'll be honest, I probably should have put in my formula up here, I should have put the approximately equal to in that little formula. Okay? Because really, it's going to be close, okay, but it's not going to be perfect. So again, when I see this formula, I know that I have to add up x times f. So I'm going to try and find some column to make x times f so that I can add them up. Okay? So you notice that's what I've done down here. Here is your distribution with the midpoints. Now what if I ask you to do this and I don't give you the midpoints and I just give you the class spots? Like maybe it was I don't even know what this would be. We could figure it out. Let's say it was 10 to 12. Well, 11 would be your midpoint. That's what you would use, right? Okay, so make sure you watch out for that. X does have to be the midpoint. So you would go ahead, you would take X times F, and let's face it, that's 12.5 times the 6, right? That's X times F, is 75, right? Okay, this next one I got, 24.5 times 10. I think I can figure that one out. 245. Okay. And what you would do is keep multiplying them, because I know in my formula I have to add them all up. Okay, so there they are. I know we can all handle that calculation, so I will spare you that. I think for some of you the hardest thing is if I don't give you these nice little setups, can you make the setup yourself? I think that's where a lot of people bog down. Look at the formula, find out what you need, give yourself that column, and get it. Okay. So now I have to sum it up for my numerator. So if I sum this up, I got apparently 2,089. Is that what you got for your numerator? Okay, so my numerator, 2,089. So do we think that if I were to add up all my data entries that it would be exactly 2,089? If I actually had them. Is it possible though? It's possible. Do you think it's within reason? Is this pretty close? Yeah, this is probably pretty close. Is it perfect? Probably not. But probably pretty darn close. And let's face it, there's no way for us to get around this anyways. I can't go get all the data. So now I have to divide by how many there were, and the easiest thing to do that is just add that up. Apparently there was 50 of them. So X bar approximately equals that. And so approximately equals, I got 41.78, something like that. Yep. Now look at your frequency distribution over there. Do you believe 41.78 is a reasonable mean for that data? Like an average? Yeah. Well, how come it's not higher or closer to, say, the 84 that's at the bottom? How come it's not closer to that one? Yeah, there's only 2 of them, exactly. So you notice here, maybe even throwing that one, that's where most of the power is going. And that 6 even throws in power. Does the 2 really give you a whole lot of power there? Not really. It doesn't give that 84.5 a whole lot of contribution to that calculation. Where I would say the 10 and the 13 and the 8 do carry the greatest power because there's more of them, right? Okay. Now let's face it, we could have sat here and added 12 and a half 6 times and 24 and a half 10 times, and we multiplied to make it quicker. Everybody's clear on that? Okay. So any questions so far? Doing good? All right, here's some shapes of distributions. This very first one is symmetric. I'm hoping you can see why they would call that one symmetric. If you put a line vertically down the middle and folded it, don't you believe that it would line up pretty darn close? Okay. Very few times will it line up perfect. Okay. But it does look very close, correct? And so it's called symmetric. Notice then, I think we can agree that the mode would be somewhere in the middle here then, correct? Because it happens the most. The median, again, what the median is saying is that half of the data entries are that way and half of the data entries are that way. Do you agree with that? Okay? Right? So it would be? Okay, because it is very symmetric, so that should happen. Then they also said that the mean is also in that location. Like I told you earlier, is it possible for the mean and median to be the same number? It is, especially if it's very symmetric. Okay? Because what you're going to do is these are going to carry the same weight as those. So if I were to average them out, wouldn't it kind of come to the middle? These will kind of average out those, right? You get that? And so in other words, this is going to average out that, and isn't that pretty much what I just drew for median? All that stuff's going to keep averaging itself out, okay? So that's what's called a symmetric distribution, and we're going to give that particular one a different name a little bit later. Uniform distribution. Okay, again, most of you don't take the time to break that word down. There is a form. They all have the same one. Uniform. That's why when you're on a team, you all have a similar looking outfit because it's one form, all right? And so what about, well, notice what's missing from here is the mode, right? Do you agree, once again, that the median does cut it? Half the data is that way, half the data is that way. And this, for the mean, this one cancels out that one. This one averages with that one to be into that middle value, correct? So they are in the same spot. These next two are going to make you think a little bit differently. One is skewed left, the other one is skewed right. Many times, students believe that I put the wrong label on the wrong graph. I have not. Because what this means, skewed left, means that there is data over here to the left that is kind of altering my calculations a little bit. Because if it was symmetric, do you agree we would go right back to that other one? But here there is stuff on the left that is pulling one of my answers for sure in this direction. Which one, the mean, median, or mode, is really getting pulled by that data over there? The mean's getting pulled the most. Is the median also getting pulled a little bit? Okay, but is it getting pulled as much as the mean? No. And how about the mode? Is that really getting pulled by that data? No. If these weren't here, would I change my answer for mode? Okay, for mode, would I change my answer? Would my answer, if these weren't here, would my answer for the other two change? Big time. Which way would they slide? They would slide to the right. So do you see what they mean by skewed left? Is there is data, like a little tail over here almost, right? That is pulling those calculations this way. Does that make sense how I'm saying that? Or should I try it another way? So the mode, I think we can agree. Now the median did get pulled a little bit, but once again, about half the data is that way and about half the data is that way. Okay, and I would agree that once we get to a certain point, I'd say this one kind of averages with that one, right? This one kind of, these two kind of average with that one, right? See how that works? So those average. So how come my mean pulls this way? Because what averages with that to keep it in the middle? Nothing. So why does the mean get pulled this way? Because there's nothing to cancel those off and average it to the middle. You see that? That's why it's called skewed left. You agree it's really the same thing happening here. It's just going the other way on this other one. This data over here is pulling those data over. And which one gets pulled the most? The mean. Why? Because every single entry carries the same weight. Like that 84 we had earlier was used in the mean. And in a calculation, was it used in the median? Not really. Okay? And so it pulls the mean further than it's going to pull the median. In the mode, it's going to do nothing too. Do they even have it in the right spot? Oh, yeah, they do. Okay. So question on skewed left or skewed right? You see how your brain has to kind of maybe think of that a little bit differently? Because you probably thought it was backwards. Okay. Anything else? Because I think that's it, right?